I want to talk about the law of sines. The law of sines basically is the ratio of a side of a triangle to the sine of the angle opposite. In other words, the length of side A divided by the sine of angle A, and that's equal to the side of B divided by the sine of B, which is also equal to C divided by the sine of C. Here is the formula that you want to remember. It's just basically the side to the sine. Now, one of the situations that we can have is we can have two angles in one side, and that's pretty straightforward. And the reason that I say that is if I have two angles, in this case I've got an angle of 50 degrees and 75, so angle A is 50 degrees, angle B is 75 degrees. I can quickly find out what angle C is simply by taking the idea that the three angles added together add up to 180, so if I take 180 and subtract the sum of these two, which is 125 degrees, I will get angle C is going to be 55 degrees. So now I know that angle C up here on this triangle is 55 degrees. Well, that's an acute triangle. All those angles are less than 90 degrees, so there's only one solution to this. All I have to do is figure out what A and C are. Well, what I can do is use that ratio. I know that the sine of A is equal to the sine of B. Well, I know A. No, I don't know A. I know angle A is 50 degrees, so A divided by the sine of A, sine of 50, is the same thing as 12, which was the other side, divided by the sine of 75. I know that angle. I simply have to solve this one. Well, all I'm going to do to solve it is multiply both sides of that by sine 50. The sine 50 on the left side cancels, and leaving the A, the sine on the right side turns out to be 12 times the sine of 50 divided by sine 75. Now, for you folks who have a TI 30XA, what you do to enter that is you put the 12 in first. Okay, so here's the 12 over here. That comes first, 12, and then you're going to multiply by, you have to put the argument in first. 50 comes first, and then sine. And then I'm going to divide that by, first, 75 sine, and push equal. And I should get, the side A is 9.517. Okay, so I can label my triangle up here that I know now that A is 9.517. Now I've got to find this side C over here. I found C, the angle C. I found side A. I want to find this one. We're going to use exactly that same ratio. That same idea is that the sine of B is equal to B divided by the sine of B is equal to C divided by the sine of C. Well, I know B, that's 12. I know the sine of B, that's sine 75. I don't know C, but I do know that angle C now is 55 degrees. Now what we're going to do is we're going to multiply both sides of that equation by sine of 55. And what happens is that drops out, leaving my C, and over on the left-hand side I have 55 times 12 divided by the sine of 75. And we're going to do exactly the same thing for that TI 30XA. You have to enter the argument first. So if I want the sine of 55, I must write it as 55 and then sine on your calculator. And then I'm going to multiply times 12, and then I'm going to divide it by, and I want want the sine of 75. And again, I have to put the argument in first. The 75 goes in first, and then sine, and push equals, and I get that side C is now 10.8, 10.18, whatever, inches, meters, or whatever. And I can go back up and label my triangle up here. I know now that C is 10.18. And I rounded this off. It won't come out exactly that on your calculator. It'll come out a very large decimal number. Just round it off. This one I stopped at 3 places. This one I stopped at 2 places. Just follow the directions on your homework or whatever you're working on. Okay? So that's the sine if you have 2 angles and 1 side. And it's, like I said, it's pretty straightforward. Okay, the other is, what happens if I have 1 angle and 2 sides? Okay? In this case, 1 or 2 things could happen. That could be a large angle right here, and the side A could come down here, or it could be a smaller angle, and side A could come here. You've got 2 different options. It's said to be ambiguous because you can't decide what it is. An oblique triangle, the one that looks like this with a big angle here, or you could have an acute triangle like you had over here, or in fact you could have a right triangle, and you don't know. So our example here for the first thing that we're going to do is we're going to look at A is 25, angle A is 25, side A is 8, and side B is 11.426. So that's what I've got right here. I know that this is 25. I know that this is 8. And I know, okay? And you can't tell by the picture what you've got. Use the rules. I know that A divided by sine A, because I have those 2 values, is B divided by sine B. I can find now this angle, what this angle is right here, by using this formula. Well, I've got 8 over sine 25 is 11.426 divided by sine B. Now, what I can do very simply is simply cross multiply this. If I cross multiply, I have 8 times the sine of B is 11.426 times the sine of 25. I just cross those 2. Well, then what I'm going to do is simply divide it by 8 to get this value right here. Let me zoom that in a little bit. That's getting difficult for you guys to see probably. All right. Now, the truth of the matter is, what I tell my 150 classes, once you understand this, all you have to do in this case is simply swap. I can swap the 8 and the sine of theta. Now, in technical terms, those are called the extremes. Ones in the middle are called means, but the extremes are right here, 8 and sine B. I can swap them out. If I swap them out and multiply by sine 25, this is what I get right here. I know that the sine of B now is going to be 11.426 times the sine of 25 divided by 8. Now, again, if you've got a TI-30XA, it's 11.426 times, and you got to put that argument first, 25, and then put your sign. And then once you do that, then you can divide by 8, and you will get that the sine of B is equal to 0.603604532.5. Now, here's the kicker. I said that since the TI-30XA requires that you put the number in first, that 603 number is already on your screen. And if it's already on your screen, all you have to do is push second sine, and remember what that is. That's the sine inverse. It's the angle whose sine is 603, and I see that my angle that I'm interested in is now 37.1. And again, I can go back and label my triangle. Now that I know that A is 25 and B is 37.1, I know these two angles now. Well, if I know two angles, I can figure out what the third is. I simply say that C is C plus the sum of these two, which is 62.1, is C, and I simply subtract 180 minus the 62.1, and I will get 117.9, and that's my value of C. So now what do I know? Look at my triangle. I know that I was given that A was 25. I was given this portion right here. I was given that side's 8. I was given that this side is 426. We just did a calculation. We found out what B is. It's 37.1. Now I subtract here, and I can find out my third angle is 117. And we did a calculation. You do the same thing with the 16.3. Is use that sine function, or usually the law of sines. And what do I know? I know that the sine of A, right here, A divided by the sine of A is the same thing as C divided by sine C. And I'm looking for C, and I know the rest of this. I know it's 8, I know it's 25, I know it's 117.9. And again, I'm going to multiply by 117.9, and I'll end up with 16.73. And 16.3 was 16.78. I found out what B was. Once I know B, I can find out what C is. Once I know C, I can find out what I know angle C, I can find out side C. Okay, now, the problem we're going to run into is if I have one angle and two sides. Now, this is said to be ambiguous, and the reason it's ambiguous is because you can't tell what you've got. It could be that this long side right here is A, or it could be here, which changes this value of this angle right here. I don't know whether it's this big angle or a little angle. I don't know. You could have an oblique triangle, which is look like this, or you could have a acute triangle, which looks like the one that we just got finished with, or you could have a right triangle. You could have any of those three. All right, so let's take a look here. And we're going to use the same values. A is 25. Side A is 8, and side B is 11.426. Now that gives us one angle and two sides. Wow. Okay, so what are we going to do? Well, here's the rules that we have to look at. If side A is less than side B, and A is less than 90, then you've got two solutions. Well, see what I've got here. A is less than B, yes. Angle A is less than 90, so I will have two solutions. If A is less than B and A is equal to 90, that's a right triangle when you've got one solution. If A is greater than B and A is not 90, then you've got one solution. But you can't tell by the picture. You have to use these rules that I've given you up here. Okay, so let's take this scenario and see what we get. I know that A is 8, angle A is 25, B is 11.426, so I can find the sine of B, and that's what I'm going to do right here. Again, I can swap those out, and I end up with the sine of B just like we did before, 603, and I'm going to take it over here, and I'm going to find out that B is 37.1. Okay, that's that first scenario that we just got finished doing. And I know now that C could be 117.9 by subtracting that 61.2. And like I said, we just did this over here. Okay, so I've got all my triangle laid. What happens is I want you to look at the graph of the sine function. Maybe you can understand why we have to do this. The sine function fluctuates like this. At 0 degrees, the sine is 0. At 90 degrees, the sine is 1. At 180 degrees, it drops back to 0. Well, all along here, there's matching points where the sine value is the same. Any of these points that match up, they're complements of each other. Now, the points between 0 and 90 have I said complement, I'm sorry, it's supplement. The points between 0 and 90 have supplementary values between 90 and 180. For example, if you looked at the sine of 60 and the sine of 120, now 120 plus 60 is 180. Those are complementary or supplementary angles, and the sine of 60 is the same thing as the sine of 120. Let's see if I can do that on a calculator real quick just to show you. Now, my particular calculator, it doesn't behave exactly the same way as yours does, so you're going to see something just a little bit different. So if I take the sine of 60, and notice that my calculator calls for the complement after I put the sine in, I get a value of, well, changes to degrees, I'm sorry, little technical issues here. If I ask for the sine of 60, and notice that my calculator calls for the argument after I put the sine in, I get a value of 0.866. If I ask for the sine of 120, because 60 plus 120 is 180, I will get 0.866. So both the angle and its supplement have the same sine values. Now that's important to us because we found that when angle B was 37.1, it could also be that angle B is 142.9 if I take its supplement, just simply subtract it from 180. So now we consider A is 25, angle A is 25, side A is 8, but B now is not 37, it is 142.9. And side B is still going to be 11.426. I have to consider both of those. Well, I know the 25 and the 149 at 142.9 plus C will be 180. That's a given. We know that. So I can subtract the sum of those two, and I find out that C is going to be 12.1, just like we did before. Now go back to the law of sines again. 8 divided by the sine of 25 is the same thing as C divided by the sine of 0.1. Find out that C is 3.97. And what we would do is we simply multiply 8 times sine 12.1 divided by the sine of 25, just like you did before. So now we have a different triangle, and that triangle, I still have angle A is 25. I have the side A 8. I have the side B 11.426, which is the same as it was. I have the complement now of 142.9. Angle C is 12, and side C is 3. And if I compare that to what the other one was, here are my two two triangles. Keep in mind of what we're talking about. Originally, this angle right here was 37.1. Now it's 142.9. You got to consider both of those. This angle C was my big angle. It was 117. Well, since the big angles moved to angle B, this is now 12.1. And you don't know which one it is, so you have to consider both of them. And you consider both of them based upon those rules that I had up here. And those rules are, I'm looking at the side opposite the given angle. In other words, if I'm given angle A, I want to consider side A. That's the same A. We were given side B, so I can just compare this one across from the given angle to the given side. If it's less than and it's not 90 degrees, and you can tell that by just looking, it's going to be 25. Well, that's certainly not 90. Then you know you got to go through these two. If it's not, if you got a right angle, you've only got one solution. And if A is bigger than B, then you only have one solution. But use the rules because you cannot tell simply by looking at it. Alright, that takes care of the law of sines. In the next video, I'll talk about the law of cosines, and that's a little more twisted. So see if you can't read up on it and get caught up a little bit on that. And I'll send you a message about what's going to happen for the balance of the week in a day or so.